Welcome to the second half of dividing radicals. So the first half we talked about quotient rule, and I will talk about a quotient rule. We're looking at the second half of our problems here, but it's not always something that's going to really come up, as in it's going to be helpful to simplify. So let's look at it. So we have monomial denominators is what we're going to start with. That's when we have one term in the denominator. So one term in the denominator. And you can see here we do not have a radical in the numerator, so we cannot use the quotient rule. But now what we're going to do is we cannot have a radical left in the denominator in simplified form. So we need to get rid of that square root of 5. You just can't get rid of it, though. We have to actually mathematically do something that's mathematically okay. And what you do is you're going to multiply by something that's equivalent to 1. We multiply by the denominator. It's a square root, so we need to have pairs of that, of this. So we have a square root of 5 and another square root of 5. We're going to multiply across the denominator, and we're going to multiply across the numerator. We multiply across the numerator. We have 3 is on the outside, so we're going to have 3 square root of 5. And in the denominator, we have a 2, and if you would like to put a 1 in front, so we multiply the 2 times 1 is 2. And then multiply underneath the radicals, we have 5 times 5 is 25. In the numerator, we can, after you multiply, you always simplify. We cannot simplify the square root of 5, so we keep that square root of 5. In the denominator, we have square root of 25 is 5. So we have 3 square root of 5 in the numerator over 2 times 5 is 10. The last part is looking at 3/10. Can we reduce that as a fraction? No, we cannot. That is our final answer. You see, we now have a real number in the denominator, it's not just a real number, it's rational. And square root of 5 is irrational. If you put that in the calculator, it would never stop, never repeat. All right, number 10. So right now we have the square root over this fraction, 8/15. I cannot simplify 8/15, so that is not going to be helpful in this fashion. So we're going to split it up into the square root of 8 and the square root of 15. So that is using the quotient rule from up top. And then we are going to, now we cannot have the square root of 15 in the denominator. We cannot simplify that. We could simplify the square root of 8 in the numerator. And you can do that right now, but I'll wait till after I multiply. So we got to get rid of that square root of 15. It is a square root, so we need groups. We need 2 of them. We already have 1, so we're going to multiply by another one. And remember, this is the square root of 15 divided by square root of 15. That is the same thing divided by itself, which is 1. So now we're going to multiply. We have 8 times 15 underneath the radical is going to be 120. And 15 times 15, I'm doing this without a calculator, I believe is 225. The numerator, if we're going to do this off separately, square root of 120. What does that break down into? That breaks down into biggest perfect square is 4. I think it's just 4. 4 and 30. Because 30 goes in 2, 5, 3, 6. I believe that's it. So it's 4 and 30. And the square root of 225 is 15. I've had some of you ask, well, if we have the square root of the same number, can we just write 15? Absolutely you can. There's nothing wrong with that. That's perfect. That's understanding that the square root of 25 or 225 is going to be 15. Or if you have the exact same thing with square roots, that's a pair, and it's going to come out to be just 15. All right, moving on. Square root of 4 is 2, and the square root of 30. Cannot simplify any further, over 15. And the last step is to look at 2/15. Can we reduce that? No, we cannot. So that is our final answer. Moving on, we have number 11. We can look at, can we do anything with the quotient rule? And if we did, it would be something like this. But that doesn't reduce. 12/7 doesn't reduce, so I'm not going to do that. So we have 3 square root of 12. Well, actually, let me back up. I'm going to multiply by the denominator, square root of 7. So we have 3. Remember, you have a 1 here, so 3 times 1 is 3. 12 times 7 is 84. And in the denominator, remember, you have a 1 there, so 4 times 1 is 4. 7 times 7 is 49, or you could have just wrote times 7 there. And then 84 can reduce down, so simplifying, reduce down into 4 and 21. And 4 times the square root of 49 is 7. In the numerator we have 3 times the square root of 4 is 2. And 4 times 7 is 28. Keep working this out. 3 times 2 is 6. And now we look at the very end. Can we simplify the coefficients? 6/28, we sure can. And that's going to be dividing the numerator by 2 and the denominator by 2. So that's 3 square root of 21 over 14. And that is our final answer. All right, number 12. We have a square root. And I'm just going to multiply by the square root of 3a. And when we multiply this, we have 3 times 28 is 75, and 81, 84. 84. A to the 6 over square root of 9a squared in the denominator, multiplying those together. 84 can be reduced into, let's see, that's, I'm going to do this off to the side, that's 21 and 4, so 4 times 21, and the a to the 6 can be reduced down, that'll be great. And then square root of 9 is 3, square root of a squared is a. Let's carry this down. We have the square root of 4 is 2, a to the 6, square root of a to the 6 is a to the third, square root of 21 over 3a. We now can simplify not 2/3, nope, but the coefficient a to the third divided by a. Remember, you're subtracting your exponents when dividing like bases. So you have 2a squared, square root of 21 over 3. And there's your final answer. All right, moving on to the next one. This one you can actually do 2 ways. I'll solve it 2 ways. I'll break it up into, I saw quickly that you can actually use the quotient rule, splitting it up. And this here, you're going to have the square root of 8 divided by 2 minus the square root of 2 divided by 2. And that would be the square root of 4 minus the square root of 1, which is 2 minus 1, which is 1. There's one way to do this problem. Here's the other way. So we can just continue with the same thing. We have a monomial in the denominator, so we're going to multiply the square root of 2, square root of 2. There's a binomial in the numerator here, so we're going to distribute. Square root of 2 times the square root of 8 is the square root of 16 minus 2 square root of 2 times the square root of 2 is the square root of 4. Denominator, multiply your monomials there. You have 2 times 2 is 4. After you multiply, look to simplify each individual term. So square root of 16 is 4. Square root of 4 is 2. And the square root of 4 is 2. Let's keep simplifying. 4 minus 2 is 2. Divided by 2 in the denominator is 1. So either way, it works for this problem. The next problem, I would not use the quotient rule. You can do some simplifying there, but it will end up being very haphazard, like it just won't work out very nicely. So I'm actually just going to take and divide by or multiply by the square root of 12, the denominator. We have a binomial in the numerator we need to distribute. So remember, you have a 1 as a coefficient out in front of the square root of 12, so 3 times 1 is 3. 12 times 2 is 24. Square root of 6 times square root of 12 is the square root of 72 over square root of 12 times the square root of 12 is 144, or some of you think I have a pair of 12s, so it's just going to end up being 12, which is great. Square root of 24 can be reduced into 4 times 6. 4 is the biggest perfect square. 72 can be reduced into 36 and 2. 36 is the biggest perfect square. And 144 square root is 12. Let's keep continuing this down. We have 3 square root of 4 is 2 in the first term in the numerator. Square root of 36 is 6. Square square root of 2 in the second term of the numerator, and the denominator is 12. We have in the first term of the numerator, we can still go with 3 times 2 is 6, plus 6 square root of 2 over 12. There are no like terms in the numerator to combine. There we have 6 square roots of 6, and we have the square root of 2. Those are not like terms, but what we can do is our coefficients. 6, 6, and 12 are all divisible by 6. So we divide by 6, divide by 6, divide by 6. And our final answer is 1 times the square root of 6 is the square root of 6. 1 times the square root of 2 is the square root of 2 divided by 2. That is our final